All right, let's go through the process again. Different setup, but same steps. So let's start with our auxiliary. So that's 3m squared minus 6m plus 6. I notice I can take a 3 out. I can try factoring. It doesn't look like it's going to happen, which means I'm going to have to do some quadratic formula. So m equals negative 2 plus or minus the square root negative 2 squared minus 4 times 1 times 2 all over 2 times 1. Oh, this has an imaginary feel to it. Let's see, 4 minus 8. So yeah, negative 4 over 2. So 2 plus or minus 2i over 2, which is 1 plus or minus I, which tells us that our complementary solutions look like C1 e to the x cosine x plus C2 e to the x sine x. Okay, and more specifically, we now have a y1, which is e to the x cosine x, and we have a y2, which is e to the x sine x. Okay, so I just kind of briefly wrote what the formula that we're modeling after is. So I want to find the Wronxian of these two y1s and y2s. So setting that up, I get e to the x cosine x, and let's see, derivative of that would be e to the x cosine x minus e to the x sine x. And then the other one is e to the x sine x, and the derivative there would be e to the x sine x plus e to the x cosine x. And I want to cross multiply. Let's see if I'm going to get anything. I don't want to do too much in my head here. Let's see, e to the x cosine x times e to the x sine x plus e to the x cosine x, and then minus, and I'm going to run out of room, so I'm going to scroll over, e to the x sine x times e to the x cosine x minus e to the x sine x. So I can see a few things are going to cancel out here. So that piece and that piece are going to cancel out, and I'm going to have e to the 2x cosine squared. Okay, let me write out what I'm seeing. So I get e to the 2x cosine squared x plus e to the 2x sine squared x, and so I can factor out e to the 2x, which is going to be cosine squared x plus sine squared x, and that is equal to 1. So e to the 2x is our Wronxian. Yay! All right, so let's go set up W1 and W2. Okay, so I set it up, and as I set it up, I realized we had not formally defined what f of x is in this case. So let's go right back to our original function and have that conversation. Okay, so our f of x is looking at the left side after I've verified that the leading coefficient of the first term is 1. So since I have a 3 there, that means I got to divide every term by 3. So our f of x is going to be e to the x secant x divided by 3, or just 1/3 e to the x secant x. All right, so as we set it up, that's going to come up. Okay, so our W1 is 0 here, and then 1/3 e to the x secant x, and then our y2, which was e to the x sine x, and then our derivative would be e to the x cosine x plus e to the x sine x. However, that part doesn't really matter because it's just 0 when I do my cross multiply. So that's going to give me negative 1/3 e to the 2x secant x sine x, which secant is 1 over cosine. So that's actually tangent. So negative 1/3 e to the 2x times tangent x for that piece. Then to get u1, so negative 1/3 e to the 2x tangent x, and I'm dividing that by e to the 2x, so that's just negative 1/3 tangent x. And then I want to take the derivative. I'm sorry, I want to take the integral of, rough morning for me where I'm doing this. Let's see. I'll put a negative 1/3 out. Integral of tangent x dx, which I believe is the natural log of cosine. Okay. All right. W2 would be, let's see, e to the x cosine x, and then its derivative, so that would be e to the x times negative sine x plus e to the x cosine x. And I got a 0, and then I got 1/3 e to the x secant x. So that would be 1/3 e to the 2x cosine x secant x. And we just had that reminder that secant x is 1 over cosine, so that is just going to give us 1/3 e to the 2x so I want to take that 1/3 e to the 2x, divide that by e to the 2x, and that's just going to give me 1/3. And I'll integrate 1/3 dx, and so that's just 1/3 x. And so now we can put all of this together. So our solution is going to look like C1 e to the x cosine x plus C2 e to the x sine x plus 1/3 ln cosine x e to the x cosine x plus 1/3 x e to the x sine x. Whew, say that 5 times fast.